Today we're going to review properties of parallelograms and look at a couple of proofs using them. So we have our standard parallelogram, and under the parallelogram we have other shapes that all fall under the definition of a parallelogram. So the parallelogram itself has a couple of basic properties. Opposite sides are congruent, and opposite sides are parallel, so I can mark it up with the arrows. The other thing about parallelograms is the fact that their diagonals bisect each other. So I can mark it like that. So each half is congruent. Now under parallelograms we have rectangles. Every rectangle is a parallelogram. So the rectangle will have all of the properties that a parallelogram has. Opposite sides are congruent and parallel, and diagonals bisect each other. But what makes a rectangle the way it is the fact that we also have a right angle. So that's what's special about a rectangle. It's a parallelogram with one right angle to it. And the diagonals not only bisect each other, but they are congruent as well. So I'm not going to put all those markings that I have up here down here. We already know, since a rectangle is a parallelogram, it's going to have everything up here. Opposite sides congruent, opposite sides parallel, diagonals bisect each other, but the two extra things are the fact that it has a right angle, so adjacent sides are perpendicular, and the diagonals bisect each other, and they are the same length. So the length of this diagonal is the same as that one. Now another type of parallelogram is a rhombus. A rhombus has all the properties of a parallelogram, but it also has adjacent sides congruent. So all four sides are the same length. And its diagonals, they bisect each other, but they are also always at right angles. So that's what makes a rhombus, that's what distinguishes a rhombus in the family of parallelograms. Again, I'm not going to put all those other markings on here, but opposite sides are congruent and parallel. The diagonals bisect each other, but then the diagonals are also perpendicular to each other. Now a square has a property of the rectangle and the rhombus. So a square is both a rectangle and a rhombus. It has consecutive sides congruent. It has consecutive sides at 90 degrees, and its diagonals bisect each other and are at 90 degrees. So a square has all the properties of everything above it: rectangle, rhombus, parallelogram. So if I want to show what we're going to do on the next page is I'm going to prove some of these things. If I want to prove that a quadrilateral is a parallelogram, all I have to do is prove one pair of opposite sides parallel and congruent. I could also just show that the diagonals bisect each other, and that is sufficient. If I want to prove a rectangle, I got to first show it's a parallelogram, and then either show that the diagonals are equal to each other, or it has one right angle. For a rhombus, I show it's a parallelogram and consecutive sides are equal. And then for a square, I can show it's either a rhombus or a rectangle, and then show the property of the other one. So if I show it's a rectangle, that means it has a right angle. I also have to show that consecutive sides are congruent. Or if I start with consecutive sides, then I got to show it's a right angle. Or the diagonals are equal and they are perpendicular. So you have lots of things, or lots of ways to prove these things. So what we're going to do next is just walk through a proof to kind of show you how to do this with quadrilaterals. So here we have a basic quadrilateral proof. I'm given that ABCD is a rectangle. So when I'm given this, that means I can use all the properties of a rectangle. So ABCD is a rectangle. M is the midpoint of AB, and I want to prove that MD is congruent to MC. So what I'm going to do is I'm going to use rectangle properties. If I look at my diagram, if I'm trying to prove these sides are equal to each other, if you look here, I have two triangles. I think I'm going to try to prove that these triangles are congruent, and then I can go back and say that these two sides are congruent. So I'm given that ABCD is a rectangle and M is the midpoint. So let's start with the midpoint. If M is the midpoint of AB, I can write a congruent statement, and it's going to be AM is congruent to MB. That's by definition of a midpoint. So I write it and I mark up my diagram there. Now, rectangles are equiangular, so I don't even have to say that these are 90-degree angles. I can just say angle A is congruent to angle B because rectangles are equiangular. And then I also know that rectangles, the opposite sides, are congruent because rectangles are parallelograms. So I can say DA is congruent to CB because in a rectangle, opposite sides are congruent. And we're left with two steps. Hopefully I can get them on here. I now have a triangle congruence. I have side, angle, side. So that's enough to say that triangle MAD is congruent to triangle MBC by side, angle, side, which finally lets me go back and say that MD is congruent to MC. MD is congruent to MC, and that reason is corresponding parts of congruent triangles are congruent. So this is an example of how you can use rectangle properties or parallelogram properties to get triangles congruent, to get other pieces of those triangles congruent. For this next proof, we are going to be given that ABCD is a parallelogram. And we're given the fact that the diagonals are perpendicular. AC is perpendicular to BD. And I've got to change that. That says C, that needs to say D. And what I want to prove is that ABCD is a rhombus. So to show it's a rhombus, we already have that it's a parallelogram. So if I can show that two consecutive sides are congruent, that's enough to show it's a rhombus. And we can't use the fact that the diagonals are perpendicular because we're going to use that to get triangles congruent to then show that corresponding or consecutive sides are congruent. So here's my goal. I'm going to get triangle BEC congruent to triangle DEC. And here's how I'm going to do that with perpendicular lines. We know that perpendicular lines form right angles and right angles are congruent. So I can say that angle BEC is congruent to angle DEC. Perpendicular lines form right angles, and right angles are congruent. So I have this. I also know from parallelograms that the diagonals bisect each other. So I can get BE congruent to DE. So let me fix my color here. Okay, I got BE is congruent to DE. That's because in a parallelogram, the diagonals bisect each other. The diagonals bisect each other. Okay, so I can also get EC is congruent to EC, and that's reflexive. Once I have that, that's enough to get the triangles congruent, because I have side, angle, side is congruent with side, angle, side. And then after that, I'm going to use CPCTC to get consecutive sides congruent, and then I can say that the ABCD is a rhombus. I might run out of room here, so let me see what I can do. I got triangle BEC is congruent to triangle DEC. And that's by side, angle, side. Oh, I think I can just barely get it in. And that's enough to say that BC is congruent to DC. Corresponding parts of congruent triangles are congruent. And I can say ABCD is a rhombus. Here's why. ABCD is a parallelogram with congruent consecutive sides. So that's a way we can use parallelogram properties and triangle properties to prove that quadrilaterals are either rectangles or rhombuses or squares. And we will practice more of this in class tomorrow.